So class, let us move on to measures of variability. So the first measure of variability that we will discuss is the range. So the range is the difference between the highest and the lowest values in a given set of data. So the range is equal to the highest value minus the lowest value of the data set. So let's have our first example. Compare the range in the two sets of data consisting of the wages per week of 8 clerks in each of two companies. In company A, we have the data, and so with company B. Since our data is arranged in ascending order, we can easily spot the highest and the lowest wage. So the highest wage here is 1,680 and the lowest wage is 1,500. So the range in company A is 1,680 minus 1,500, and that is equal to 180. In company B, our highest wage is 1,850 and our lowest wage is 1,500. So our range in company B is 1,850 minus 1,500, and that is equal to 350. Now let us move on to the standard deviation. This is another measure of variability. So it is a measure of variation of set of data in terms of the amounts by which the individual values differ from their mean. It is considered the most stable measure of spread and is usually preferred in experimental and research studies where in-depth statistical analysis is involved. It is affected by the value of each data. To find the standard deviation of ungrouped data, we use the formula. The standard deviation is equal to the square root of the summation of d squared all over n, where s is the standard deviation, summation of d squared is the sum of the square deviations, n is the number of items, and d is the deviation from the mean, or that is the value minus the mean. So we have an example here. Calculate the standard deviation of the given scores in an algebra quiz. So we have the set of data containing 10 items. So we have the step 1, calculate the mean. So mean is equal to the total of the items divided by the number of items. So that is equal to 170 all over 10, or 17. Next, we will construct a table of values for scores, deviation from mean, and squared deviation. So since the scores are given, let us get the deviation from the mean. So the deviation from the mean, or D, is equal to the score minus the mean. And we know that the mean is equal to 17. So 18 minus 17 is 1. 20 minus 17 is 3. 22 minus 17 is 5. 15 minus 17 is negative 2. 16 minus 17 is negative 1. 12 minus 17 is negative 5. 17 minus 17 is 0. 21 minus 17 is 4. 10 minus 17 is negative 7. And 19 minus 17 is 2. Now let us square the deviation. So the square of 1 is 1. The square of 3 is 9. The square of 5 is 25. The square of negative 2 is 4. The square of negative 1 is positive 1. The square of negative 5 is positive 25. The square of 0 is still 0. The square of 4 is 16. The square of negative 7 is positive 49. And the square of 2 is 4. So we can get now the summation of d squared, and that is the total of the square deviation, which is equal to 134. So now let us substitute the computed values in the formula. So the standard deviation is equal to the square root of the summation of d squared, and we got a value of 134, and our n is 10. So that is the square root of 134 all over 10, which is equal to the square root of 13.4. So our standard deviation is the square root of 13.4, which is 3.66. The dispersion of the set of data is small if the values are closely clustered about their mean, and that is large if the values are scattered widely about their mean. So it means that if the values in our data are close to our mean, then the dispersion is small. And if it is widely scattered, or the values of our data are far from the value of our mean, then the standard deviation that we will get is large. Now let us move on to the standard deviation for group data. So for large quantities, the standard deviation is computed using a frequency distribution table. This table contains columns for the midpoint value, the deviation and its square, and finally the product of the frequency and the squared deviation. In finding the standard deviation of a group data, we use the formula: the standard deviation is equal to the square root of the summation of fd squared over n, wherein s is the standard deviation, the summation of fd squared is the sum of the product of frequency and squared deviations, and n is the number of items, and d is the deviation from the mean, or that is x minus mean. So let us have an example. Let us try to use the data of the arts and crafts shop to calculate the standard deviation. The first step here is to prepare the frequency distribution with appropriate class intervals and corresponding frequency. So that is our first step. So the class interval in our amount in pesos and the frequency or the days are given. So what we are going to do next is to get the midpoint of each class interval. That is on the third column. That is the x or midpoint. And that is our second step. So to get the midpoint, we will get the middle number in our intervals. So that is 172 to 180. So if we are going to count, that is 172, 73, 74, 75, 76, 77, 78, 79, and 180. So we have 9 class intervals. Since that is odd, we know that in 9, the fifth term or the fifth number is the middle or its midpoint. So from 172, we will count 5, 172, including 172. So that is 172, 173, 174, 175, 176. So the midpoint or our x in the interval 172 to 180 is 176. Our next interval is 163 to 171. So from 163, we will count 5, including 163, that is 163, 164, 165, 166, and 167. So our midpoint in the interval 163 to 171 is 167. And so with the rest of our intervals. The third step that we will do is to find the values for the column fx. So we will just multiply f or days or the frequency by the midpoint. So fx now is 3 times 176, and that is 528. 5 times 167, so that is 835. 9 times 158, and that is 1422, and so on. So next to that is we are going to sum up our fx. So the summation of fx is equal to 6041. The fifth step that we are going to do is to compute the mean. Using the formula, mean is equal to the summation of fx over n. And in our data, the sum of our frequency or the days is 40, and that is our n, and the summation of fx is 6041. So we will be needing those values in computing the mean. So substituting the values in our formula, that is 6041 divided by 40, our n. So our mean now is 151. So we have already computed the mean. And with that, we are now ready to find the deviation of x from the mean. So in finding the deviation, that is x minus the mean, or the midpoint minus the mean. So 176 minus 151 is 25. 167 minus 151 is 16. 158 minus 151 is 7, and so on. The next step now is we are going to square the deviation. So the square of 25 is 625. The square of 16 is 256. The square of 7 is 49. The square of negative 2 is 4, and so on. So we are now ready to find FD square. So we are now close in our formula. So in finding FD square, we are just going to multiply the frequency by the squared deviation. So 3 times 625 is 1,875. 5 times 256 is 1,280. 9 times 49 is 441, and so on. Going back in our formula, that is the square root of the summation of fd squared over n. So we need to sum up our fd squared in order to get the value of the summation of fd squared. So if we are going to get the total of our fd squared, that is equal to 7,531. Since we already found the value of the summation of fd squared, we are now ready to substitute the computed values in the formula. So that is the standard deviation is equal to the square root of the summation of fd squared, and that is equal to 7,531 divided by our n, which is 40. So that is the square root of 188.275, or that is equal to 13.72. So that is now our standard deviation.